Greetings everybody. So with our last classes we covered first two chapters of Microeconomics by Daron, Acemoglu, David Leibson, John A. List. The syllabus for semester 1 students of Delhi University who have chosen economics as their major. So yes, in last two chapters we studied like what is economics. It is a study of choices and its consequences. So the third chapter, optimization, which is the principle of, which is a very important principle of economics. We're just studying optimization in detail. Okay, so the chapter starts with a question like how does location affect the rental cost of housing? So in the beginning we are not discussing it, which we'll detailedly look in later in this chapter. So the question is basically about how like the rent changes when you choose an apartment close to the city center, and the commuting time, the rental cost of that house, how all these affects you. Okay, so we are leaving it for time being. And next is 3.1. In total this is a very short chapter, just having three main topics. So the first topic is optimization, choosing the best feasible option. So in our life, in our day-to-day life, we are optimizing. Okay, we are just going for the best option which we can afford. From our morning breakfast to the college which we are studying in, and what to say, to the bus that we are traveling or any transportation mode, we're just going to optimize everything. We're just selecting the best option for us in our affordable, which are affordable for us. Okay, so economics is a study of choice. Economists usually assume that people make choices by trying to select best feasible option given the available information. That is, people try to optimize. We have discussed this point very detailedly, like what is this given, what is this available information and all in last chapter, so I won't be going through that again. You can just go over the last chapters again and again, it's in the playlist. So economists use optimization to predict most of the choices that people, households, businesses and governments make. Whatever choices people face, economists believe that they will try to choose optimally. However, they don't assume that people always successfully optimize. Okay, next is how to optimize. So two different techniques are given. The first one is simply calculating the total values of each feasible option and then picks the option with greatest total value, that is benefit minus cost. The benefits that we get while traveling via a cab minus the cost of traveling through a cab. And we'll next alternative option is for public transportation is metro. So benefits that we get while traveling through metro and the cost of metro traveling through metro. So cost, benefit minus cost, just we'll get the total value. Next is marginal analysis. The second technique for optimization is marginal analysis. It focuses on difference among feasible options and finds best option by analyzing these differences. So we'll be studying these two techniques in detail in this chapter. So this chapter is completely for studying the two techniques of optimization. So first is behavioral economics. Let's see what is the connection with behavioral economics. So first of all, behavioral economics jointly analyzes the economic and psychological factors that explain human behavior. In economics, we solely study the economic factors that explain human behavior, but in behavioral economics, we jointly analyze the human behavior with the factors of economic and psychological elements. Okay, so behavioral economics explains why people optimize in some situations and fail to optimize in other situations. As we said, Economists assume people try to optimize, but they does not state that people always succeed in optimizing. So that is what behavioral economics explain. Why people fail to optimize. Okay. So several special situations are associated with behavior that is not optimal. One is procrastination, then addiction, and if you are provided with a new task, that is if you are new to the stock market, you cannot optimize. You don't know how it works, so you won't be able to choose the best option. So in these three, not three, there are many. So in such cases, uh, an economic agent or a human fails to optimize. Optimization is a better description of behavior when people have lots of experience. Okay. So John Campbell, then Tarun Ramadurai and Benjamin Ranish documented this pattern of improving performance in a 2014 research paper. They obtained anonymized data that summarized the activity of 11.6 million investors in India. The researchers found that experienced investors have annual returns that are on average 4.6% points higher than those of their inexperienced peers. The authors named their paper after the Beatles song Getting Better. The paper name is Getting Better and began the paper with this lyric, it is a little better all the time. Okay, that is, it can't go no worse. Because people aren't born perfect optimizers. Okay, people aren't born perfect optimizers. Optimization is a useful skill to develop. So let's step to 3.2, which handles with the first optimization application of calculating the total value. So here we are considering the example of rental apartments, renting the optimal apartment. So you are provided with 4 apartments. The first is very close to city center, the second one is close to city center, then it is far from city center, and the fourth apartment is very far from city center. And you will take for the commuting time, for traveling and everything, 5 hours, 10 hours, 15 hours, 20 hours respectively. With the rent is provided here, I'm not reading it out. Okay. If the benefits are same, then cost benefit analysis becomes simpler. That is, total value analysis becomes simpler. Find alternative with highest value of net benefit. Net benefit means benefit minus cost. Okay, we have studied all this in the last chapter. So here, so to find the total cost, what will be the total value here? That is total cost. It will be the rent, direct cost of rent plus the commuting time, indirect cost of commuting time. Here commuting time is given in hours. For calculating the total, the cost benefit analysis, we need everything in a same measurement. So here for calculating the total cost, we have the direct rental cost, and then next we need indirect cost for commuting time. So we are converting into a common unit of account, that is dollars per month. Here we are calculating the opportunity cost. We studied all these terms in last classes. It is not it won't be good if I repeat it again and again, the video becomes more lengthy. So opportunity cost, the cost of next foregone alternative. Okay, so if you're using this 5 hours of time for any other activities like any part-time job, how much you will be earning? So here we are giving this 5 hours, not 5 hours, here we are giving the commuting time and earnings of $10 per hour. So we got the direct cost, then for the indirect cost of commuting time, we are charging it at $10 per hour. when if you are investing this particular time of commuting to any other activities of generating income, you may get 10 dollar per hour. So for round trip it will be 20 hours. $20 per hour. So, okay, round trip it will be na, morning you go, evening you come. So how we'll be calculating? So we got the commuting cost. For the first one it is 5 hours, very close apartment, that is A, it is 5 hours. So the commuting cost is $50, then $100, $150, $200 respectively. That is, you multiply the commuting time with $10. So we can calculate the total cost, that is rent plus commuting time. Okay, these are given here. And here when we check the total cost, the cheapest option is C, that is far. Then you will only be costing $1,108. Rent plus commuting time cost only $1,108. That is the optimum point. Optimum means it is the best feasible option. So I have marked it here. It is the optimal point. So this is a time graph. Here I have marked. So for very close it cost 1,230 rupees. Then for close 1,190 rupees. Then for far it is 1,180 rupees. Then for very far it is 1,200 rupees. So this is the optimum. That is the best feasible choice available here. Again, there is one more thing which is not in use in the first technique, but in the second technique it is useful. So I will be explaining it now itself. If an option has to become the optimum, the very before option has to be the very before option and the very next option has to be worst. So here the close is becoming expensive, that is, it is a worse option for the consumer, and the very far is also expensive, so it is also a very worse option, a bad option for the consumer. So in the middle we have optimum, so that is the best option. You'll be understanding this concept with the coming examples. So 3 steps of optimization using total value. First, translate all costs and benefits into common units like dollars per month. Then calculate the total net benefit of each alternative. Then pick the alternative with highest net benefit. Okay. So next we are increasing the commuting. So in the next example, we are increasing the commuting cost per hour from $10 per hour to $15 per hour. So here we will be for getting the commuting cost, we will be multiplying $15 with the commuting time. So the commuting cost is as such $75, $150, $225, $300 respectively. Then adding both this commuting cost and rent gives us the total cost. So here there is a difference. So what is the difference? The cheapest option is the apartment which is close. So when the commuting cost increased from $10 to $15, the cheapest option of apartment is which is close. Okay, so that I have marked here. In the first option, this was the optimum. When the opportunity cost was $10 per hour, this was the optimum. But when the opportunity cost is $15 per hour, this is the optimum. It is in the close. Why it changed? Let's see why it changed. I have detailed explanation. Okay. When the opportunity cost of time increases from $10 to $15, it becomes more valuable for the commuter to choose an apartment that reduces the amount of time spent commuting. Right, because it is more valuable for him to use those time in doing his work. Whatever alternative choice may be for doing that hobbies or work, it is more valuable than the commuting time. So the optimal choice switches from a relatively inexpensive apartment with a longer commute that is far, to a relatively expensive apartment with a shorter commute that is close. $10 per hour cost curve lies below the $15 per hour and hour cost curve. So $10 per hour curve has a lower commuting cost for each apartment, so the total cost is lower for all apartments, lower than all apartments. Okay. So next is optimization using marginal analysis. So here, this is much faster to implement than optimization using total values, because this method focuses only on the ways that alternatives differ. Marginal analysis is a cost-benefit calculation that studies the difference between one feasible alternative and the next feasible alternative. So just two are considered here. Cost-benefit analysis between one feasible option and the difference between one feasible alternative and a next feasible alternative. It compares the consequences, that is cost and benefits, of doing one step more of something. Marginal analysis will never change the ultimate answer to the question, what is ultimate? The answer that we get from both these techniques of optimization will be same. But marginal analysis will clarify the way that you think about optimization, because it focuses on what is changing when we compare alternatives. Okay. So next is marginal cost. It is the extra cost generated by moving from one feasible alternative to the next feasible alternative. So when the opportunity cost was $10 per hour, the apartment far was the feasible option. It was the optimum. So here we are calculating the marginal commuting cost and marginal rental cost. That is the additional amount that you will need to spend to move to the next option. So for very close ABCD, that is for very close, it was 15, the commuting cost. Then for moving from very close to close, that is from moving from very close to close, you need to spend extra $50, that is from $50 to $100. Extra $50 in commuting cost, that is marginal commuting cost is $50. Again, when you move from close to far, again you are spending $50 more. Then you are moving from far to very far, you are spending an extra commuting cost of $50 again. Okay, so the marginal commuting cost here is $50. Then coming to the rental cost, when you are moving from very close to close, the rental cost have decreased by $90. That is, marginal rental cost is minus $90 because it is decreased. That is why minus $90. Then when you are moving from close to far, again decreased by 60. Then when you are moving from far to very far, it have again decreased by 30. And next, coming to the total cost. The total cost is also decreasing, first by $40, then $10, then it have increased by $20. Okay. First it decreased, then it again decreased, but then it increased. So this minus $10, that is far is in between the worst options. That is, if the commuter move from this point to anywhere, to back or to front, he will be worst, in a worse position. Next is, we can calculate whether far itself is the optimum in two techniques, in both the techniques of optimization. So moving from very close to close, the marginal commuting cost plus marginal rental cost, we are adding both the marginal cost. Okay, so it was $50, then it was minus $90, right? You can check the table here. So you will be getting minus negative 40. Then with the so this is the marginal analysis technique. This is the marginal analysis technique. Next is the cost benefit technique, the total value technique. So the total cost of close is the commuting cost plus rent is $1,190. Then for the very close apartment, it is $1,230. The difference is minus $40 itself. So with both the techniques, you will be generating a same the same optimum itself. So fine. The cost minimizing choice is far. Total cost is falling when marginal cost is negative. That is when the marginal cost is negative. So first the marginal cost was minus 40. Then the total cost decreased from 1230 to 1190. That is TC is falling when MC is negative. When total cost is rising, then MC is positive. So here also, when it moved from close to far also, when the total cost decreased from 1190, the marginal cost was minus 10. When the marginal cost is positive, then the total cost is increasing. That is, from far to very far, the marginal cost increased by plus $20. Then the total cost also increased to 1190. Okay. Far is the only apartment that satisfies the principle of optimization. So that is what we discussed in earlier. That is, this particular principle, that is principle of optimization at the margin, states that an optimal feasible alternative has the property that moving to it makes you better off and moving away from it makes you worse off. So optimization using marginal analysis will always pick out a single optimal alternative when total cost curve as is like a bowl-like shape. So here you discovered it, na? This is like a bowl-like shape. Let me draw it again. So here the TC curve is like in a bowl-like shape. So when total cost fall, then MC will be negative. Marginal analysis recommends moving farther away from the city center, thereby lowering the total cost. After total cost bottoms out, marginal cost becomes positive, implying render should move no farther out. That is why MC become positive. So now the steps of marginal analysis. Translate all costs and benefits into common units, that is dollar per month. Then calculate the marginal consequences of moving between alternatives, that is the marginal rent, marginal commuting time, marginal total value, the additional amount that you need to pay to move from this point to the next point. Then apply the principle of optimization at the margin by choosing the best alternative with the property that moving to it makes you better off, moving away from it makes you worse off. So that's it with the third chapter. We are done here with the third chapter. And yes, so in next class we can start with the fourth chapter, demand, supply and equilibrium, which is quite a lengthy chapter. Probably I'll take 4 classes to complete that chapter. So that's it. Happy learning.